Good morning, everyone, and welcome to the presentation of use of non-destructive testing in the determination of predict models for the estimation of the second elastic module and compression resistance of concrete produced by the company SOBOCE.SA in the Metropolitan region of Cochabamba. Before continuing, I want to introduce myself to the audience present this day. My name is Andrés Ignacio Jaramillo Herrera. I was born in a city located into the south of Bolivia called Tarija in 1998. I am currently 24 years old. I am a research student at Bolivian Private University. I am also a technical advisory intern at the company SOBOCE.SA. My main goal as a civil engineer is to get a master's degree in structural engineer. 5 qualities I can describe myself that I am very positive, disciplined, confident, hardworking, and a fair person. Continue. The research project was developed in 2 places in Cochabamba, Bolivia. The first place was in the ready-mix SOBOCE.SA concrete production plant that you can see here. And then part of the research was carried out in Bolivian Private University. Here you have some photographs about the ready-mix SOBOCE.SA concrete production plant and then of the Bolivian Private University. The general objective of this research can be presented as determine regression model that helps estimate the second elastic modulus and compressive strength of concrete produced by the company SOBOCE.SA in the Metropolitan region of Cochabamba with stone aggregates from alluvial banks of the Parotani River and BH brand of IP40 cement through the application of non-destructive testing methods in concrete. On the other hand, the specific objectives can be presented as complete the phase of experimental tests on different types of concrete in the laboratories of the company SOBOCE.SA Cochabamba and at the Universidad PRIVADA Boliviana, determination of regression models through the collection and processing of data obtained from the compressive strain, elastic modulus, ultrasound wave velocity, and Sclerometer test. Finally, the validation of regression models through the comparison with previous equations. The test methodology implemented consisted first of all in 4 parts: identification of variables to study, compressive strain, ultrasonic pulse velocity, Rebound index hammer, and modulus of elasticity. Execution of 300 compressive strain tests, 300 ultrasonic pulse velocity tests, 150 Sclerometer tests, and 60 of modulus of elasticity tests. Application of procedures as ASTM C31, ASTM C39, ASTM 597, ASTM C805, and ASTM C469, and the analysis of the effectivity of each model found. The measurement equipment used to reading the ultrasonic pulse wave was the ultrasonic tester Pundit PL200 from Process brand, and to reading the Rebound index was the Sclerometer harness tester Silver Schmidt, also from Process brand. Finally, the measurement equipment used to reading the modulus of elasticity consisted first of all in a data logger, 3 encoders that record the unit strains, a load cell that was in charge of recording the force applied by the loading press. Here you can see all the equipment ensemble. The test execution methodology consists first of all in the elaboration of 300 concrete cylinders with dimension of 15 by 30 centimeters of concrete mixtures with design resistance from 18 to 35 megapascals reached at 28 days. They were tested from 3 to 90 days. The tests applied were ASTM31, ASTM39, ASTM497, ASTM805, and ASTM469. In order to study better the samples, all the samples were divided in 5 groups of 60, each group determined by a design resistance, and were tested in subgroups of 10. Regarding the granulometric characteristics, the dosage used for each characteristic resistance reached at 28 days are present in the next table. In the second table, we can see the composition of this IP40 cement of BH brand. Width is under the specification of ASTM T150. And finally, the granulometric curves that are within the limits established by ASTM C33. In this section of the presentation, we can see the model between the compressive strain and ultrasonic pulse velocity. We can see that has a very good relationship coefficient of 0.955 and present a linear form. In the second slide, it can be seen that we have a linear form also and have a very good coefficient of correlation of 0.929. Related to the previous model present, a regression model could be found, and that was this one. This combined the ultrasonic pulse velocity and revolve hammer index, and with two of these we can estimate the compressive strain. In this section, we're going more into what is the estimation of modulus of elasticity. It was possible to find a classic model between the modulus of elasticity and compressive strain. It presents an exponential form. It also has a very good relationship coefficient. To further enrich the investigation, other models were also found that relates the ultrasonic pulse velocity with modulus of elasticity and the modulus of elasticity with the Rebound hammer index, as you can see. In order to validate the regression model presented, a bibliographic search was carried to look forward to other similar models developed around the world. In the first table, we can observe models concerning to the compressive strain and ultrasonic pulse velocity test, which shows important parameters that helps us evaluate the effectivity of the proposed models. These parameters are the test prediction ratio, the standard deviation, and the root mean square. In the second table, we have models that are related with the hammer test. We also found combined methods developed around the world that have very good parameters. And finally, we could find also other models that describe that have a very good relation coefficient and very good parameters also. Two of them are from the American Concrete Institute. In order to analyze and compare the models present before, the following graphs were prepared, which shows us the effectability of each one. Here we can see the prediction ratio of each one of the proposed equation and the previously cited models. For example, in the case of ultrasonic velocity method, we can see that the model of Architectural Institute of Japan, the Turgut model and KIP model has very good prediction ratios as the proposed equation. Then in the Rebound hammer test, we can see in a similar way that they have very good prediction ratios. And in the combined methods, two of them have the major prediction rate as the proposed equation. In the next graph, we can see about the modulus of elasticity. We can see finally in the second graph that refers to the elasticity modulus of elasticity, the proportion obtained from the proposed model and the European Concrete Committee presents a slightly higher proportion than those of the American Concrete Institute. Finally, we have reached the following conclusions about this research project. In this study, the proposed estimation equation that use a dual regression approach in conjunction with Rebound hammer test and ultrasonic pulse velocity method show the highest accuracy and the lowest RMCA in predicting compressive strength. The quality of the concrete evaluated through the experimental process has a very good quality. This was deduced from the range of ultrasound wave speed, which is between 3,800 to 4,800 meters per second. It was concluded that the difference between the values obtained by the models elaborated with respect to the other estimation models is due to the composition of cement, the characteristic of aggregates used for the elaboration of concrete, and the model of measurement equipment used. The models that predict compressive strength through the ultrasonic pulse velocity and Sclerometer rebound index present prediction efficiency quite similar to those of the models presented by other authors in different parts of the world. Thank you.
Any question from the audience? Question?
Yeah, Andres, thanks for the question, for the presentation. What type of cements were you testing? Was it just different water cement ratios, or did you test any with SCMs?
Well, the difference is this one is what you asked for. These are the properties.
Mm-hmm.
As we can see, there is not much difference. The difference between the cements, the aggregates are around from North America respect South America, is that we use a different type of rock, that is the andesita rock, and this gave more elasticity to our concrete. For example, we also have different type of chemical composition, different type of proportion in the ratio of water cement.
Okay. Do you think you could use those same formulas to predict, say, if you used a 50% slag replacement, or if you had a fly ash to your mix, or would you need to do different tests?
Well, this equation were found with the purpose of just study the concrete of the region of Cochabamba to adapt our circumstance to these models, no? So I don't think it would be useful to analyze other type of concrete.
You need to do another 300 tests then, I guess?
Yeah.
Okay, thank you.
So related question is like, why do you think your models can have a better performance than the other regression models?
The principal problem that we have in Cochabamba is we bought this equipment, the ultrasonic tester and the Rebound hammer. We didn't have the correct regression that are adapt to our circumstance. They were just generic from the equipment. Maybe this equation have been found with other concrete that is not ours. So we can be sure that it's describing to the 100% sure our concrete is the first principal objective of this presentation. But these models can be used for other people if they want to have an idea if their models are close to the characteristic of these aggregates used, these materials used for these samples, help them to have a better validation for their models. No?
Very nice. Thank you so much.